Hello, 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 and welcome to the walkthrough, the CSM official system walkthrough for the fall 2020 midterm one. So we're going to first go over what made Python print that option problem. So let's just jump right into it. So these kind of problems, to be honest, are like pretty somewhat intuition based, and we have to just look at and I'll just go over my thought process for these, but it's a lot of pattern recognition, and so in my personal opinion, you probably have to train yourself to do this rather than like something you know, like as a concept of knowledge, but it's rather something you gain from experience and practice. But anyways, let's just go over this. So we're going to return this, and we're iterating over range len vals, and we're given this vals array. So one thing you'll notice, like the thing you have to notice all this problem, right, is that this we can actually map the first array to this first list to the second list, right? So this is this plus 0, this is this plus 1, this is this plus 2, this is this plus sorry, this is this plus 3, this is this plus 4, and this is this plus 5. So that's like the thing you have to notice in order to like have hope on solving this problem. That like the way we're doing it is that we're doing 10 plus 0. This new list is just 10 plus 0, comma 50 plus 1, comma 60 plus 2, comma 23 plus 20 plus 3, 40 plus 4, 30 plus 5. So recognizing this pattern is unintuitive and if you didn't recognize this pattern, don't beat yourself up over it. Just try and just like I guess if you practice more, you'll have a higher probability of chance of like seeing something like this. But if you did see this pattern, then that's like now is the time that we can like have a concrete way of solving the problem. Now that we see the pattern, so what are we doing, right? We're taking the value of, if you notice, right, we're taking the value, right, of in the vals list, and we're adding its index to it. So that's like kind of cool, actually. Like thinking about it like that, you don't have to think about it like this. You can just say that, oh, we're adding 0, 1, 2, 3, 4, 5 to it, and just increasing numbers, and that's why we're using range. So what will this return? This range then vals is just 0, comma 1, comma 2, comma 3, comma 4, comma 5. So yeah, so looks like we have all these numbers ready for us inside our range. So that's good. So let's start with the easy part first. So number 2, we're doing something for something in something, right? This could literally be anything, right? This could be X, this could be Y, this could be your mom, this could be anything. So let's just say X. So yeah. So now that we have like a variable for it, now we have to do like sort of the hard part, which is like, what is each value? As I mentioned before, each value inside this new list is the value of the old list plus the index, which is X plus X. So it's as simple as values of X plus X. Obviously, like once you figure everything out, it's simple, but like it's pretty hard to figure it out. But hopefully, if y'all got to this step, it's like this breakdown. Like getting to this breakdown is unintuitive for some, and like don't beat yourself up over it. If you once you got this breakdown, hopefully y'all can understand how this line works. And so just for like some more clarity, we can rewrite it like this, and I'll show you how it simplifies. Vowels of 1, 0 plus 0, vowels of 1. This is what this list comprehension is doing, by the way, when we fill it like this. Plus 1, vowels of 2, plus 2, dot, 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 right? And that's just 10, 51, comma 62, dot, 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 which is like the rest of the list. So that's it for this one. Again, the hard part of this problem was finding this breakdown. If you found it, good for you. If not, don't beat yourself up over it. That's not something that you can just like think of you have to like sort of recognize the pattern. So yeah. Now let's go into this one. This one's a bit more systematic, in my opinion. So we're given this mystery function, and we're trying to get the target value is 36. And we're trying to get this target value of 36, and we want to find the three of the four inputs in for secret num, such that we return 36. So how do I approach this problem, right? So the way I think that's best to go about this is to approach from the inside out. If you notice, right, the mystery function has two ways to return a value. And so in the end, we want to return 36. So let's just say we want to return 36 for the entire thing, right? So what do we have? Sorry, yeah. So sorry, from the outside in, my bad. We're from the outside in. We want to see what this entire thing could be, such that it returns 36. Okay, so what could that be? So let's start. So we're kind of like a tree for this. Okay, so 36, and we're looking at it from this perspective. So, so n minus 15 equals 36 if n is greater than 20. So obviously, since 36 is greater than 20, n minus 15 if it's equal to 36, it's going to be greater than 20. So what's 36 plus 15? That's 51. So that's one way to get it, right? The other way to get it is by doing the n times 3 thing, if n is less than 20. But if you notice, 12 times 3, 12, which is less than 20, equals 36. So 12 also returns 36. Are we done? No, because we evaluated what this entire thing should be. Now we have to find out how we get what secret num should be, such that mystery 1 of secret num is 51 or 12. So let's start with 51. So n minus 15 case, same logic as the 36 case. 51 plus 16 is 51 plus 15 is 66. Okay. The next one is the n times 3 case. 51 divided by 3 is 17. 17 is less than 20, so this works out as well. 17 times 3 is 51. Let's go to the 12 case. The 12 case is the first one is the minus 15 case. So 12 plus 15, that is 27. And yeah, my math sucks. And since 27 is greater than 20, we will go into this case. And now 12 divided by 3, that is 4. And since 4 is less than 20, we'll go into this case. So now we have all 4 values, and just choose any 3 of these and just put that as your solution. So that's 3B. This is the explanation, but we already did the explanation. So just like write down what I said, draw the tree, make it very easy for them to tell you that you know what you're talking about before. So now let's go into problem C, and this one's like a bit of like some short circuiting logic. So right off the bat, you may be tempted to think, oh, it's always true because high is a truthy value, but you would be mistaken because one of the things with Python is short circuiting. So if we reach this high stage, right, it will not return high. It will not return true. It will return high. So the only only these 3 return booleans because they're comparators. Even though if you put like an if statement, right, high is true. If when you like print it out, it would still say high. So this is just like something that they did. I think they taught you. They taught you where it's like when you short circuit to something, it won't return the like boolean form. It'll return the actual value. Okay, so we can't just like rely on this as always true. So that's just like the first thing I want to get out of the way, because like that was when I first saw it. It took me like a second to be like, oh, it's not always true because of short circuiting. So if list 1 was 33, would the expression evaluate how often would the expression evaluate true? So if list 1 was 33, if you notice in this, right, let's put this 33, in all of these 3, only the second one uses list 1, right? So 33 is less than 15. That is false. But either of these could be true because we don't know what they are. And if either of these are true, then it's true. But if both of them are false, then it's false. So if it's not always and not never, then it's sometimes. So there we go. Now, if list 1 was 0, was 21, the expression would blank evaluate to false. So list 1 was 21. Let's see if list 1 is 21. If list 1 is 21, then 21 minus list 0. Now, we don't know what that is because we don't know what list 0 is, so that doesn't, can't say anything about that. But 21 mod 10 is not equal to 2 because 21 mod 10 is equal to 1. So that means that this would always be true because therefore it would never evaluate to false. Okay. Yeah. So those are the Boolean questions. Now, number 3, fill in the list of 3 integers such that the expression, the second line in the original evaluation evaluates to high. First answer is blah, 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 blah. Now, remember, this is going over the idea I went over at the beginning, right? Where it's short circuits to high. So that means that if we want it to be high, it means that all of these have to be false, falsy values. Okay? So, let's start with the first one, right? So the first one is sort of like the second one, where it's like if it was a number, it would return a number, and it wouldn't return high, right? It would just return a number which is truthy, unless the number is 0, because 0 is a falsy value in Python. So that means that list 2 has to equal to list 0. Okay? So we'll just keep that in mind, okay? So we'll just call them both x. X blank x. We'll fill them out later. Now, list 1's only purpose is to be greater than 15, so that it'll be false and we can move on to the next thing in our OR chain. So we'll just call it 16. And this one we're sure of, right? Because we don't need any list 1 for anything else. Now, list 0 mod 10 is not equal to 2. So for that to be false, list 0 mod 10 has to be equal to 2. So the simplest way to do this is just to let it be, obviously, 1,232. That's the simplest way to do it, in my opinion. 1,332. 1,332. As you can see, 1,332 mod 10 is equal to 2. Therefore, it's false. Therefore, it's not equal to 2. Therefore, it's false. That means we short circuit to high, and we get a solution. So yeah, so like you can explain it like that, like I said verbally, and it should be good. And that's it for our walkthrough of problem 1. I hope you enjoyed, and if you have any questions, leave them in the comment section. Thank you.